Okay, so a cone is becoming a sector. Usually, I will cut a sector and form a cone, but I want to believe that you can picture this as I try to explain. So please, please pay attention. If a cone is made from a sector, this is more or less, as far as I'm concerned, IGCSE level. So, which is why I just gave you the question to attend. And I think you guys did a pretty good job. Now, if you have this shape, and you want to turn it into this shape, you're going to have to put these 2 points together, right? And this arc becomes the circumference of the base. Okay, everybody agree? And this point here, this center here, is going to be this top here. Okay? And this length is going to be this one. You can try it from a sector at home, put it together, and just experiment. That's how I would teach someone in IGCSE class, but I don't want us to waste time cutting shapes. So, find this slant S. So, to find this slant S is to find this, and both of them will be the same. Either one we want to find first, but S can be found directly by Pythagoras theorem. Now, is there a specific, okay, it says correct to 3 significant figures. So the question never said in the exact form, which means calculator is allowed. Mind you, I think your paper 1 is no calculator, right? Yeah. In IB. So you want to really start learning to do some stuff with a calculator, which is why you have to learn exact value of something like surd, for example. And one of the things we'll be talking about in trig is called trig of special angles. We have to be able to find sine, cos, tan of some angles without the use of calculator, using exact form of trig. Okay, because those are the things I will expect. By the way, I'm already working on your exam paper. I'm done with section A. So I did it the way we did the last test. Multiple choice, then essay type questions. That's the same thing I did. So I only increased the multiple choice to 20. And they are just basic things I expect you to know. I give you a shape, for example, give you 2 functions. I'm just giving you an example. I'm not saying it's part of the question. And I draw something like this. And I say this is F, this is G. I say which of the following is true about F and G? Oh, F is an inverse, a G inverse. Oh, G is F inverse. Second option. Third option. Oh, both options A and B are true. Oh, none of options A and B is true. Something like that. So it's not calculation, it's just to recall those key concepts. Do you understand? Okay. Oh, which of these is positive definite quadratic function, for example? So you have to remember, what does it mean for a function to be positive definite? And of course, I know there are over 1,000,001 things that we learned, but you don't know where IB comes from. So when you start, getting yourself timed, question, that's when you know how much you can actually recollect, and that is the goal for next year, maybe. Do you understand? It's not just to give you one test and you want to get 99 and impress your parent. I don't care about you impressing your parent. I care about how you survive when you start that either economics program, engineering program, pharmaceutical program, forensic science, pure math, whatever you want to study in the future. That's my concern, not to impress your parent about your graduation. I don't care about that. Okay? All right. 9. A. So we look at Pythagoras theorem. Yeah, one thing I noticed from the 3 questions, the 3 submissions that I received, is that some of you sketch and some of you did not. And when you are sketching, your sketching should really, really make sense. You want to be impressive, you want to communicate your ideas. In this, there's no problem. But in question 12, I noticed somebody was trying to draw the shape. What I would do in an exam is to draw that shape as perfect as possible, which means I get to use my compass to draw a circle. Do you understand? You are communicating an idea. You are not, doing some rough work. Okay? So please take note. So half of this is 6, this is 10, and this is S. Okay? Then we use the Pythagoras theorem. S squared equals 10 squared plus 6 squared. So which is 100 plus 36. So x squared is 136 implies s is square root of 136. In 3 significant figure, what is that? Quickly, please. 11.7. So that's that. That's 9a. B. 9b, find the value of r. All you have to do is, since s is equal to r, it implies that r is equal to this, which is also 11.7. Okay. C. Arc length of the sector. Okay. Arc length of the sector is the circumference of the base. So I would love you to explain. Okay. Even though we didn't explain here. What do you mean by s is equal to r? We're saying the slant height of the cone is the radius of the sector. That's what I would have said in words here. Okay. So in this case now, arc length of the sector, I'll say since arc length of sector is the same as arc length of the sector is the same as what? Perimeter of the base of the cone. You're just trying to sound convincing. Okay? Arc length of the sector is, remember, instead of theta over 360, what is the arc length of sector? Because is the angle in radian? We don't even know. Okay? Nobody said anything about the angle being radian. So if we use that, then we might as well just go directly into it. So I'm just going to do it as if, okay, nobody said anything until the last part, that angle in radian. So let's just work with normal degree that you are used to. So arc length of the sector, theta over 360 degree times 2 pi r. Now, but the radius of the sector is, yes, r. Circumference of the base of the cone, somebody wrote pi d, which is fine, or 2 pi r. Remember, this d and r are not the same. Okay? So if you are going to write this as 2 pi r, which is the perimeter of the base, then you can do r1 here, r2 here, because there are two different r. But to be on the safer side, you can just write pi d. Does that make sense? Because of course there are two different variables, so we cannot assume that they are the same. So we need to be careful. So we can as well just change this if we want. So instead of this, you can just use pi r directly. It's fine. Then we know whatever we do is in terms of what? Is in terms of is in radian. But since we are not really interested in that, anyway. Now, arc length of the sector. Okay. Then we don't need this. Arc length of the sector L. Okay, it's just this. So we can use it. Why do we need this to get that? Because we have the radius here. So we actually don't need what I just wrote. Sorry about that. So that is pi d. Pi times diameter is 12. So 12 pi in 3 significant figure is what? The instruction is for A, B, C, D. So do not stop at 12 pi. Okay? What is 12 pi quickly? Some of you did it. What? 37.7. That's the arc length. Okay? And last but not the least, angle at the center. So that's when we need what I just wrote. Okay? So from L equals C, circumference or perimeter. Okay? Just say arc length from above. From C, for example, arc length is 12 pi. Okay, so this means the 12 pi is what? The length of the arc, right? So length of the arc is theta over 360 times 2 pi. But because the angle has to be in radian, you don't use theta over 360 times 2 pi. What do you use? Theta r. Theta times 2 pi r, I mean. Remember? Theta over 360 times 2 pi r. Because 2 pi and this are the same. When you convert, then you are just dealing with what? Theta r. Okay, so this is equal to theta r. And what does this r represent? Radius of what? Radius of what? Sector, which is r, and is already here. Okay? So when you are doing this, please, even though we want to substitute the value of r, before then, That's right. Theta equals 12 pi divided by r. Now it's time to substitute. 12 pi, you see, I didn't write this. I wrote the exact form. Similarly for r, you need to use the exact form. Because if you do that, this is approximated value, this is approximated value. You cannot get a better answer if you use two approximated values to get it. So now, somebody put this in the calculator and tell us what you have. Theta is what? Say that again. I mean, this is what you should put in the calculator.
3.23.
3.23 radian. Did you get 22? 23. If you don't use the exact, you might end up getting 22. So because you approximate prematurely by using the final result instead of that one. Do you understand that? Okay, so quickly, let's move to question number 2. The second question is from number, oh, come on, make it fast. Why are you so slow? Okay. From this. Now this question reminds me of one competition that I always tell you guys about, Cowbell National Math Competition. I mentioned that in your Form 3 about the goals is tied to a particular point. Does everybody remember that? Where two fences meet? I give you that question. I'm sure I mentioned it in your Form 3. Something like, so the question sounds this way, and you might want to think about it too. So a goat, just like this sheep, is tied to a point where two fences meet at angle, for example, 120 degrees. So this is a fence, this is another fence. So the owner tied the goat here with a rope. The length of this rope is 9 meters, for example. Let's just assume that's 9 meters. So the first question is, how large is the portion of the land, for example, with which the goat can roam? So the goat is probably here, even though there's enough rope. So the maximum the goats can extend, the maximum area the goat can get to is the length of this rope, right? And so the goat can move in this form, and that forms a sector. Okay? So the portion, how large that portion is simply saying what is the area of this sector. I think that was our question that year. So Cowbell Mathematics Competition 2001 or maybe 2002, I can't remember. So when I taught my students over the years, I will put another part of the question that what is the maximum distance the goats can move from one part of the fence to another? What am I asking? What? Somebody say something? At length. Because if the goat can move from here to this place, right? The goat can move in different ways, but the maximum is when the goat goes through the arc. While others are just shortcuts, right? So there are two questions. If you are looking at the region, talk about area. If you are looking at the maximum distance, you talk about the length of the arc. Okay? So when I saw this question, it reminds me of that math contest problem that I did those years. That particular year. All right. A sheep is started to a post, and which is 6 meters from a long fence. So this is it here. This is the fence. The length of the rope is 9. So find the area with which the sheep can feed on. So let's say this is grass. So the sheep can feed on by going in a circular form. But then this is blocked already. So we are looking at a shape that looks like this. So this is the fence. So in this case, if I want to do this problem, I take my compass, I draw a circle. Now it's just sketch. That's the point I'm trying to make. Okay? You have to try to present your work properly. So I'm going to draw a circle. So this is the center where the sheep stuff is. And let's see. I know it doesn't look like a good circle. Please don't tell anyone my circle is horrible. Okay, so I draw the circle first, for example, then we can make use of this.
That circle is actually really nice.
Yeah.
Yeah, it's actually a really good circle.
It's time to make me feel good. Thank you, sir. Anyways.
Did like your birthday just like
Mm-hmm.
under your circle game?
So birthday circle. Alright. So basically, this is 6. But the length of the rope is 9. So any other points, this is 3, for example, because everything has to be 9. And any other part is also that. So we're going to just try to form right angle triangle. This has to be 9. Okay? So we don't know anything. We don't need any real thing anyways. We don't need anything yet for now. We're looking for the area of this portion. So when we talk about where the goats can feed, we're talking about this. So we're looking for the area of that region. Okay? So basically, that is area of a major segment. You know segment and sector? You know the difference? Yeah.
I think it's once every year.
No. There are some things that normally, if I have, let's say IB diploma program is a 3-year course, and I'm going to be with the class for 3 years. There are some things that are not in the syllabus that I will put in the syllabus, so that when I'm teaching those things in the syllabus, you understand what I'm saying. One of them is spending time on part of the circle. But of course, we have to skip that. So I'm just going to quickly rush through that quickly. Now, if you have a circle, let's discuss some part of the circle. And if you forget, you can always watch the clip later, especially this point. Some of the part of a circle that I like to discuss in trigonometry is to start with the radius. Of course, everybody knows what the radius is. It's that distance from the center. Radius is the distance. Okay? So the radius of a circle is 5 centimeters. We're saying the distance from the center to the circumference, any part of the circumference is 5. Okay? We only represent it by a line. The radius is not a line, basically. Do you get my point? Anyway. Alright, the radius, the distance from there to there. One other thing I like to talk about after the radius is the chord, not diameter. Okay? Or maybe I put it the other way. Anyway, never mind. The chord is any straight line from one end to another in a circle. Any straight line. You have a circle, this is a chord. You have a circle, this is a chord. Any straight line from one end to another is a chord. So, this is a chord, and this is also a chord. This is a special chord called what? Diameter. So all diameters are chords, but not all chords are diameters. And diameter is always the longest chord. Okay? And the length of that diameter is twice the radius. Does that make sense? Now, then I always try to remind people of a tangent. It's a line drawn outside a circle to touch at a point and perpendicular to the radius. You must have done some theorems in circle geometry that if a straight line is a particular popular theorem in circle geometry, any line drawn from the center of a circle to bisect a chord which is not a diameter, which means is not this, the one that passes through the center. Any other chord, it could be here. Any straight line that comes from the center to bisect this must be perpendicular to it. That's a theorem in circle geometry. So that's why we always form a right angle triangle. We talk about the length of the chord, the distance of the chord from the center, and the radius. There's a theorem you must have learned in IGCSE and there. So this is why did I mention this? Oh, it's not even related. I don't know why I mentioned that. Anyway, that's a right angle. That's a right angle. I thought it was related, so I recall that theorem. Now, after these lines, then I like to discuss some fraction of a circle or part of a circle, starting with maybe a quadrant. A quadrant can be actually be assessed here. It's 1/4 of a circle. Everybody knows that. So those are regions. For the others, we can talk about length and whatever. Here we talk about area because it's a region. It's not a distance. Then, after that, I'd like to talk about a sector. A sector is a region in a circle bounded by two radii. That's the plural of radius, just like child and children. Okay? Bounded by two radii and an arc. Any region in a circle, bounded by two radii and an arc. So you have a circle, this is a sector. Because this is radius 1, radius 2, an arc, then this part is a sector. Similarly, this part is also a sector. Because it's bounded. Bounded means surrounded or fenced. Okay? Radius 1, radius 2, another arc. The question is, how do we differentiate between the bigger and the smaller? Then we use words like minor or major as adjective. Minor sector, major sector. Does that make sense? I remember a tricky question in my days. You know, normally if I tell you the area of a circle is 44 centimeters squared, find the radius of the circle. It's very easy, right? Area of a circle is 44 centimeters squared. Find the radius of the circle. So you do pi r squared equals 44, isn't it? Then you do necessary things. Is that? So one tricky question that we were given back then, that would normally be given, not in my final exam, was instead of saying the area of a circle is 44, then you get something like the area of a minor sector of a circle is 12, while the area of the major sector of the circle is 32. Find the radius of the circle. You've given me the area of the circle indirectly, because the minor plus the major combined gives the whole circle. Does that make sense? Because these are some of the tricky ideas that you might need even in the topic we are doing right now. That's why I'm mentioning this stuff. So, that's a sector. The last part, or second to the last part, is a segment. A segment is a region bounded by a chord and an arc. What is a chord? Any straight line. So, this is a minor segment, this is a major segment. Do you understand that? Because this is a chord and an arc. Of course, your arc also can be a minor arc and a major arc. The smaller one will be minor, the rest will be major. Do you understand what I mean? So, after this, I like to discuss semicircle, which of course everybody knows as half of a circle. Then I like to ask a question. Is a semicircle a sector, a segment, or none of them, and why? We know a semicircle is half of a circle. Is it a sector, is it a segment, or none of them, and why?
Is it both?
It's both. Why?
Because a sector is where it's bound by.
It's a region.
Yeah. It's bound by two radii and an arc, which is 160 or pi. And then it's also, what was the other one?
Segment.
Segment. It's chord.
It's chord. What do you mean it's chord?
It's
Bounded
bounded by a chord.
by a chord and an arc. Yes, it's right. A semicircle is a sector and a segment at the same time. Because according to the definition, or whatever we can say, whether definition or explanation, a sector is bounded by two radii and an arc. If you look at a semicircle, this is radius 1, radius 2, and this is an arc. So yes, it's a sector. A sector that subtends angle 180. There was no discrimination. It also has an angle at the center. Does that make sense? Then, why is it a segment? Oh, a segment is bounded by a chord and an arc. Yes, it's actually bounded by the longest chord. Not just the chord, but the longest of the chords and an arc. So yes, it's a half of a circle, it's a special sector, and it's a special segment at the same time. Okay? Now, why did I mention this? Back to this. This is a segment. So that question is actually asking you for the area of the major segment in the circle that you have sketched based on the word problem. How do we find the area of a segment? Normally, it's always area of a sector minus area of triangle. especially the minor segment. Why? Because if you look at this, part, that's a sector, right? So sector is actually segment plus triangle. Can you see that? So which means segments is actually sector minus triangle. Okay? Now area of sector, we know. Are you with me? We know how to find that. Theta over 360, blah, blah, blah. Right? Area of triangle, then we use half AB sine theta. Remember that formula? Raise your hand if you know the formula that I'm talking about. To find the area of a triangle, half AB sine theta. Everybody knows? You know? Okay, good. And that's how we find the area of a segment. So whenever you come across this, it will come in handy. Okay? So back to this original question. Some of you did this, I'm sure, even those that didn't turn it in yet. I'm sure you have done a good job, but I didn't want us to leave any stone unturned because we're not spending classes on this, where I will give you different questions. So I thought we'd just go through with the example, the exercise together, especially because of question 15. So, we need this angle, because when we find this angle, double the angle can give us angle at the center, right? So to actually find the area of this region, you can divide it into two. So there are two ways actually. You can find the area of the minor segment and subtract from area of everything to find this one. So it's your choice. And to find the area of minor segment, you have to do sector minus triangle, like I just explained now. Another way is to divide this into two itself. Find the area of this sector, find the area of this triangle, and add. And that's what I think most of you did that's turning that work. That's what you did. So that's fine. So how do we find the area without knowing the angle at the center, which is why you need to work out the angle first. So we use our SOHCAHTOA. If this angle is alpha, for example, opposite is here, so we are dealing with adjacent and hypotenuse, and that is cosine. So you have to use cosine of alpha is equal to 6 over 9, which is 3. We don't even care about the 3, simplified form. Alpha is arc cos of 6 over 9. Yes, please. What is that? 0?
0.84.
This is
0.84.
okay. Maybe in radian. Is your calculator in radian? No, I'm talking about arc cos, not 6 over 9.
Yeah.
Are you in radian or degree?
Ready?
That's radian.
Yeah.
Okay. 0. What?
84.
84.
Yeah.
Okay. Maybe we leave it in. Give me 4 digits first.
1, sir.
No, 1.
1, 1. Okay. So which means the angle at the center, if I call that theta, for example, this is alpha, and this is theta. So basically, theta is 2 alpha, which is twice this. What's that? 1.6822?
2, 1.
2, 1?
2, 1.
I thought this is 1, 1.
I
Anyway.
think they times the whole thing.
Yeah, maybe the times your 10, that's fine. Okay, 2, 1. So now we can find then everything is, so this maybe if I call this the angle here, maybe beta or something. So beta is 360 minus theta, right? So which is 2 pi minus that. So what do you get?
4.6.
4 point? Oh yeah, yes. 4 point.
0.
0. Quickly.
6, 0.
6, 0.
6, 0.
4.6010.
6010, like that. So now that we have all the angles, then the work can be done. So maybe we can put here. So area of, so basically if you want to do this, can you see? Area which the ship, remember one of the IB requirements is to be able to communicate. You're not just showing up that you can calculate. You want to communicate your idea. This is a word problem. It's not calculate area. Alright? So area which the sheep, can feed on is equal to, okay, is equal to what? How do you get whatever you want to do? Area of triangle plus area of sector communicates. Okay? Area of triangle is half AB sine theta. Communicates.
That's done.
Yes, sir.
Do you write like major sector?